Hello there. I'm just going to take you through a little bit of a presentation, part of which is part of the presentation I gave at the Power Up Live event on the 18th of May down in Hursley. This will do as a kind of introduction into the demo that I will then also put forward. So this will hopefully help you along. I'm David Spurby. I'm the Power Systems Product Manager for the UK and Ireland, and so I just wanted to start off this particular presentation by introducing you to a couple of my friends from university. This is Jackie. Jackie was my neighbour in the third year of university. This is Lawrence. Lawrence was a friend of mine at university. Lawrence and I did the same degree, and Lawrence and Jackie and my wife and I all had an entertaining evening. There may have been some alcohol involved in third year, and they got on quite well in that particular evening, and as a result they've ended up getting married and moving out to America, and these are their two kids. But I'm showing you Lawrence at this point is because in his final year he did a sort of project based entirely around neural networks. That was back in 1995, but even back in those days we were talking about this kind of technology, but we're now at the stage where we can really begin to make real use of it and move forward from there. So there we go. So I'll take you through a little bit about sort of big data and the AI client journey. You can move through 4 different sort of stages of working with data: observation, interpretation, evaluation, and also decision. So observation is kind of the world where you can work in a descriptive form, what has happened. That can be viewed as a sort of traditional analytics, where you're looking back into the past to be able to pull out answers from the data that you have available to you. Interpretation is predictive, what could happen. That's more using the sorts of likes of Cognos or those sorts of elements, so sort of software group products that can actually look at what could happen in the future based on the same sort of data. You can also get into the world of evaluation, where you can come up with a prescriptive approach as to what the best possible outcome might be. That could be using the sort of SPSS tools, or it might be using I2. A variety of different software products exist that have all been programmed to be able to do that. And then finally you get onto the space where you don't program it, but you learn instead, the cognitive learning dynamically kind of world instead. So to give you a couple of examples of how that might work, you can have maybe the descriptive sort of thing might look at how many frauds occurred during last month in any particular given country. I've recently had an experience of this myself, in that my parents had a case where they were the victims of fraud, where my dad got a sort of message over his phone, and then a significant amount of money was transferred out of their savings account, and so that was then picked up as to something that had happened, and thankfully the bank was able to then sort it out and fix it. It did happen, the money did leave their account, but it was able to be picked up pretty quickly using a sort of observation approach. Something's gone wrong, something's happened, and therefore they were able to get the money back. Maybe a better way, however, would have been to use a kind of predictive approach, where they can actually maybe see the transactions will be fraudulent and stop them before they are. So that would have been maybe a better way to do it. You could also look at what the best possible action in the light of potential fraud is, to be able to take a range of options, not just stop the transaction, but maybe to make your decisions as to what you wanted to do based on the evidence available, and decide what you want to do moving forward. And then finally you've got the kind of cognitive piece at the end, where you can actually exchange in natural language. My dad could maybe have got the phone call through from this particular system. It could actually have talked to him and explained to him why this particular transaction was fraudulent, given the evidence that he could see, and he could talk back and agree or disagree and move forward in some kind of automated but learned fashion. So big data covers the sort of area where you have prescriptive and predictive and descriptive, and those are the kind of more traditional analytical approaches that we've got a number of programmed approaches to be able to move forward with. Then you've got the bit on the right, which is more talking about the artificial intelligence world, where you aren't necessarily programming the system, but instead you are letting it learn dynamically, and that can be described as deep learning, which sort of works within a number of different pieces here, can call upon the big data information and also add in the machine learning as well. You can work with natural language processing and your knowledge base, and maybe build a robot to be able to react in some kind of automated approach. So with machine learning, what you do is you can start off with a significant quantity of data. You can prepare that data so you end up with a considerable quantity of it being training data. That can lead through to being able to do machine learning algorithms, which can actually give you some kind of predictive model. You can then take a separate set of the data and test out how the learning's gone and what kind of reaction it gives you from your predictive model, and then you can see what kind of accuracy you end up with it at the end of the day. That tends to be the sort of process where it's an iterative development. You end up preparing the data, building some kind of training model, and this building and training is what we're really, really good at with the GPUs in our power systems. You can deploy and score, monitor, refine, and then maybe go round and again. So in my demo, I'll take you through an example of how my data is not perfect right now, and we could maybe put some more data into the training kind of phase and be able to make it actually more accurate in certain cases and iteratively deploy it. You can do this with lots of different kinds of frameworks. I use Caffe for the piece that I'm working with because I'm working with images, but there are lots of different options out here. TensorFlow is very popular with Google, for example. Then you can also move through into lots of different use cases by industries. You can use the recognizing patterns, face detection, spoken words, maybe look at this sort of transportation or security kind of world. You can extract insight from text and video, avoid spam, and you can do things maybe in a healthcare kind of world to do this. We talked a little bit about financial fraud already, so you can discover anomalies, be able to react to that in some kind of way. Sensor readings can also give you some kind of manufacturing optimization kind of areas. You can make predictions, maybe that's in stocks and trade or client behavior, and then be able to move forward in that kind of space. So this is an article that was put up on the OpenPOWER blog site to be able to talk about what's going on. So there's lots of information there about what they're going on with the server that's involved, which particular framework they use to be able to go through this sort of process, etc., etc. And then it talks about the fact that they are using the Stanford dogs dataset. So I'll just open that in a new tab and we can have a quick glance at that. Stanford dogs dataset, as it says here, is 120 different dogs with 20,000 rather different images of dogs, and you can see all the different types of dogs that we have down here. And so we can see a number of these, and so you can click on the dogs themselves and you get a load of pictures of dogs, and they're all sorts of different types. So you can see that we have little puppies that are going on here, which are frankly very cute. Then you have the sort of larger varieties of dogs, all the different types, shapes and sizes, but of course all these particular ones are Bernese Mountain Dogs. And that means that when I go back into my system, so back into dog classification demo, then I can choose myself one of the pictures of dogs, and so I can choose that from the files that I've got already, which are just pulled straight off the internet in this particular case. So I can take my walking carpet picture and it is able to work out this is definitely a Bernese Mountain Dog, and it is really sure that it is a Bernese Mountain Dog. Similarly, I can take another dog, so I can take my scary version, and that is Pop, very clearly a German Shepherd, a very sort of identifiable dog that after all, and it is very certain that this is a German Shepherd. We can do this with a couple of other ones as well, so I can take some slightly more challenging cases. Let's go for an example. Let's see, I think, is that the one I want, or is this the one I want? Let's see, so let's go with this one. And so this one is clearly not off the internet, all these ones has popped up. So that is my little boy, and he is indeed stroking a Newfoundland. Great big dog, and we're fairly sure it is a Newfoundland. So it's able to work out that my little boy is not a dog, but that is what it's interested in, and looking at the Newfoundland dog and going forward from there. Then I can also take another one, so let's go with this, and this brings us back to Pop, Bernese Mountain Dogs. So this is my daughter stroking a Bernese Mountain Dog, and so the dog lying down sort of in an interesting pose, lots of other things going on in the picture, so it's not quite so sure, but it is indeed quite correct that it is a Bernese Mountain Dog. Now, it doesn't always work, so just to be fair about this, we have other information here. So if I bring myself up a picture, let's see, I think it's this one. Then this one reports that my daughter is in this case stroking a Rottweiler, and she is not. It's not a Rottweiler she's stroking at all. It may well be a Greater Swiss Mountain Dog, but it's not quite sure about that and doesn't get it quite right. And then I can also choose another one. So if I take my sausage dog, if I take myself a standard picture I've pulled off the internet of a Dachshund, it really doesn't understand what that is at all. It doesn't know what it is. It thinks it might be black, but it's not really sure about that. It thinks it might be a Doberman. And actually, when you look at the face, it's not necessarily so crazy as to think that it might possibly be a Doberman, but it isn't, because it has these crazy little short legs. And the reason for that, just to flick back to my data set here, is that in here we have no, as I scroll down to the D's, we have C's, we have the beginnings of the D's, and we have a couple of different dogs with beginnings of D's, Dobermans there. There are no Dachshunds in the dataset. So if I wanted to get it more accurate, if I wanted to be able to have it actually be able to identify this particular Dachshund, what I'd need to do is give it a bunch of pictures of Dachshunds, put it in with the rest of the images that it's already working with, and then be able to go around that, and then it would be able to identify those. So it just shows that we do need to actually do this iterative process of learning, which of course is what power systems are so good at, rather. Then finally, now that we've finished the demo and the introductory presentation, of course, feel free to come and ask me questions. If you want, you can email me, you can give me a call, and we'll explore that as you need. Okay, thanks so much indeed for your time, and I hope that's been useful for you. Speak to you soon. Thanks. Bye now.